Okay, today let's start with a quick introduction. How many ways are there to write the number, for example, 150? 150, for example, simplest way is just 1 times 150 lah. Right, that's 150, isn't it? Can I write it as maybe 10 times 15? Are they the same thing? What about maybe 100 times what? Times 1.5, okay. Still the same thing, right? Can I go on and on? I think I can keep going on and on forever, right? For example, let's try one more. 1000 times 0.15. Okay, can I go the other direction? Maybe 0.1 times 1500, yes? Same also, right? What about 0.01 times 15000? Are they all the same? And I can go on and on. Okay, what's the point about this? I'll show you later. Besides 150 written down this way, can I write, for example, another number? 150000000. Okay, let's try this one. Right now, as you see me writing 150000000, quite a bit to write. Okay, but I can express it in many ways again. For example, 1 times 150000000. I can express it in another way. For example, 10 times, so I have to be very careful now. Right? Are they the same thing? Okay. What about are they the same? Okay. And I can go on and on. Yeah? What is a convenient way to write it then? Probably, let's see what happens. 10 to the power 8 times 1, 2, 3, 4, 5, 6, 7, 8. 10 to the power 8 times 1.5. For example, this is what he chose. So I can go on, I can continue some more. 10 to the power 9 times 0.15. Right? On and on, either this way or the other way. Now, they are all referring to the same number. But out of all these options, right, which one is easier to write? Suppose you need to keep referring to this huge number over here. Which number is easier to write? Do you prefer to keep writing in your working this one? Or maybe this one? Or maybe something else like maybe this one? Do you have a preference? No preference. You rather write many zeros and then you have your careless mistakes here and there. Is that what you prefer? No, right? So, given that there are so many different ways to do it, and we know just by looking, it is probably much easier to write it, to express it in one of these forms. Very few zeros to talk about, but you have a 10 to the power 8 or a 10 to the power 9. So, these seem to be more convenient ways to express your numbers. Then the question is there a standard way to do it? Can't be you leaving your answers any way you like, right? Based on your own preference. Probably there should be a standard way of doing it, so that everybody will be able to use the same format. Calculations will be easier in physics. Calculations will be easier in chemistry, in mathematics, whatever field or discipline you will use in the future. So we came up with this thing called standard form. Very creative name, standard form. That is found in page 16 of your textbook. That's our topic for today. I will go straight into how we write a standard form, okay? At the bottom of page 16, highlighted in yellow color, if you were to read, a number expressed in the form of a times 10 to the power of n. Right? Expressed in the form a times 10 to the power of n, this is a number where a is between and including 1, but smaller than 10. And n is an integer. This over here is called the standard form. Okay, let us break this down further. Over here, a is between 1 and 10, but it can include 1. Give me an example of a number for a. let's have Justin. Who's Justin? Sorry? Oh, you are Justin. Okay. She says number 8. Is that possible? Does it fall between 1 and 10? Including 1? Yes, right. Okay, what is then the smallest number that we can have for A? 1. Can I go smaller than that? I can't. If I go smaller than 1, it is no longer in this standard form. Okay? If you go smaller than 1, it is no longer in standard form. What about if A is equals to 10? Can or cannot? Can A be equal to 10? Why not? Yeah, because there isn't a smaller or equal to. It has to be smaller than 10. So it can be 9.998, 9999, so on and so forth, as long as it is smaller than 10. Okay, that is the first part over here. Okay, any questions for A? No? Then the next part. A number expressed as A times 10 to the power of n. The next part over here is 10 to the power of n. What are the restrictions? What is the base over here? 10 to the power of n. What is the base in 10 to the power of n? What is the base? The base value is 10 lah. 10 cannot change. Not up to you to change any number you like. The standard way of doing it is base 10. And what is the power? What do we have on the screen? What is the power? N. Can n be anything we like? Can n be anything we like? No. What can it be then? What did it say? Integer. So do you know what is an integer? Okay, there are counting numbers, includes 0 as well, includes your negative whole numbers. So maybe negative 10, negative 5, 8, 4. It cannot be a decimal, it cannot be a fraction. Okay, so now looking at, let's go back to our examples. Over here, 150. Which of this option shown over here gives me a standard form? 100 times 1.5. To make it more accurate, this is actually equals to 1.5 times 10 to the power of 2, right? Is this now in standard form? Yes. 1.5 is between 1 and but smaller than 10. And on the next part, I have multiplied by 10 to the power of 2. So this over here is my standard form. No, for such small numbers, 150, you may not see the value of using standard form. But what if I have this huge number over here? So which is now my standard form? Out of all these options we have over here, has the standard form appeared already? Anywhere here? Has the standard form appeared? Hey, why I don't have a sitting plan? Who is the chairperson? Still no chairperson? Okay. Then let's see, who is Patricia? Okay, yes. Can you tell me, did the standard form appear in this in all these options? You can't see? Then you move here. Okay, let's try Sherry. Who is Sherry? Yes, Sherry. Has the standard form appeared? The rest of you think, Has it appeared? It's a yes or no question. Yes, she says yes. Then I'm not going to leave it at that. So which one is the standard form? Which one is in the standard form? Since all of these are equals to 150,000,000,000, which one of these options fits in this description, where the first number is between 1 and 10 by including 1, and the second number is 10 to the power of an integer? Lost? Okay, let me help you. Is this between, is this number over here between 1 and 10? No, it's not. Okay, so can't be this one. Oh, this one. Is this between 1 and 10? No. I can keep going, right? then I reach this number. Okay, now she has decided 10 to the power 8 times 1.5, right? Okay, let's take a closer look at this. Is this in this format where we have a number that is between 1 and 10 multiplied by 10 to the power of an integer? Do we have it? Yes. 1.5 is our value for A. It is between 1 and 10. 10 to the power 8. Now obviously it is 10 to the power n, where n is equals to 8. Okay? So, anybody needs clarification on the format of standard form? None? Okay, so now we have an easy, convenient way of writing big numbers. What about small numbers? For example, let us try a very, very small number such as 0.0003. Okay, quite a small number, right? Okay, this again will be equal to 0.0, okay, 10 to the power of -4 times 3. At the same time, we have many, many options. 10 to the power of -3 times 0.3, right? 10 to the power of -2 times 0.03, so on and so forth. And I can go in the other direction as well. So question is, does any of them fall in the standard form? Which one? The first one, because by habit, I already wrote down the standard form already. Okay, this one is in standard form because this number over here is our value for A. It is greater than or equal to 1, but smaller than 10. And this number over here, this is our value of 10 to the power of n, where n is a integer. It's an integer. Integers can be negative. So -4 is not a problem. Okay? So if there are even more zeros, then we'll be able to still use the standard form of expressing them. Can? Okay, I spent quite a bit of time talking about this. So let us go into example 10 in your textbook, page 17. Okay, example 10a. Express the following numbers in standard form. So we have 6, 1, 2, 0, 0, 0, 0. Okay, don't forget, we always want it to look like this. A times 10 to the power of n. Okay, what do you think is my value for A in this question? Remember, it has to be between 1 but smaller than 10. So what's my value of A? Okay, that's the easy part. 6.12, right? This is between 1 and 10. Now, the next part, times 10 to the power of 6. How do you do it so quickly? Okay, you may realize along the way that there are shortcuts, okay? So let me show you one of the shortcuts that I like to use. In this huge number over here, is there a decimal point? Is there a decimal point? No. No, right, but I can introduce one, right? Where should I introduce the negative point? Over here. Introduce it over here. They are the same, right, isn't it? Right? I can introduce it over here. I didn't change the question. Now, I will start moving my decimal point to this position over here, because my value of A is 6.12. So as I move it, I'm going to start counting. 1, 2, 3, 4, 5, and 6. I move it over here. So this will be equal to 6.12 times 10 to the power of 6. Try with your calculator if you don't believe. Okay? Let's try another example. Maybe this is my own example. Maybe 518000. Okay, let's try this one in standard form. What do we have? What is my number for A? Okay, 5.18. Very easy. Times 10 to the power of, okay, now I need to find out what is that power in base 10. So again, I introduce my decimal point. It's over here currently. I jump 1, 2, 3, 4, 5. Times 10 to the power of 5. Simple enough? Okay? This always works. Always works. You can always go and calculate it yourself to convince yourself, okay? Because it's actually 6.12 times 10 to 3, 2, 3, 4, 5, 6. This is actually 5.18 times 1, 2, 3, 4, 5. They are the same thing. Can? Okay, now try, let's go on to part B. Part B is slightly different. It is now a very small number. So 0.000840. Before you continue on, let's take a closer look at this number over here. 0.000840. Is there a need to write down this 0? Is there a need? Did the question say 3 sig fig? Okay, so what we learned in primary school, right, is that all these zeros at the back, they don't matter at all. Right? We can just drop them. But in this case, in this particular question, they it's not a mistake, purposely put a 0 over there. Why do you think they did that? What? Why do you think they included the 0 over here? In this case, it is a significant figure. Okay, it could have been, for example, 0.1. Then they round off to 3SF and they get 0.000840. Oh, so from 4SF to 3SF. Okay, so this is the reason. So then, when I ask you to tell me the value of A, what will you say? 8.4 or 40? 40. They are significant figures. Okay, then the next part is z times 10 to the power of. Okay, now can we still use my method? I see the decimal point there, jump. Probably we can do something very similar. Okay, so now we go in the opposite direction. Initially we went to the left, now my decimal point is over here. Jump this way, 1, 2, 3, 4. Times 10 to the power of 4, yes? It cannot be times 10 to the power of 4, then you end up with a huge number, right? So it has to be times 10 to the power of -4. Okay? You see how to do it? Am I going too slowly for you? Am I going too fast? Too slow? Too slow. Okay, some say too slow. So let's pick up the pace a little bit. I want you to try 10 by yourself. Okay? Very easy one. Part A and part B. Using the method that I've taught you. And don't forget, what are the rules in your standard form? First number must be between 1 and 1, the second number must be 1 base to the power of whatever. And at the end of the day, everybody will end up with the same value for a standard form if everybody did it correctly. So the first one, to express it in standard form, just put on some working over here. It's going to be A times 10 to the power of n. I want it to be in this format. A is between 1 to 10. Can I include 1? Can I include 10? Okay, so that's the rule. So over here I will get 3.78, yes? Times 10 to the power of. How do I know it is 5? So from here, the decimal point, 1, 2, 3, 4, 5. I jump 5 times. Okay, so this is 3.78 times 10 to the power of 5. This is the answer. Now for part B, 0.000092. Okay. So the easier part is always to write down the first number. So if you notice, I always write down the number first, followed by the 10 to the whatever power. And that is the standard way of writing it. Okay, so make sure you leave your answer in this way. So this will obviously be 9.2. That's the easy part. Okay, times 10 to the power of -5. Let me check. 1, 2, 3, 4, 5. Okay, then about -5. Easy or not? So easy, right? Nobody should get this kind of questions wrong. So now let's go on to example number 11. Part A, express the following as an integer or a decimal. Now we're just reversing. So for part A, we have 4.25 times 10 to the power of 5. Please note that this is already in standard form. They want you to write the answer as an integer or a decimal. So how? This is actually the same as 4.25 times 10. Okay, 1, 0, 1, 2, 3, 4, 5. And then in your primary school, how do you multiply by such a big number? You just move the decimal point again, right? It's the same thing, just that we're reversing now. So I will end with 4, 2, 5, 0, 0, 0. Okay? Any questions? Then for part B, this is now the small number, 3.17 times 10 to the power of negative 6. It is actually equals to 3.17 times 1 over 1,000,000. Don't forget your indices. What Miss Yu taught you? 10 to the power of negative 6 is equal to 1 over 10 to the power of 6, right? So this is equal to 1 over 1 million. Okay? So as you evaluate this, you get 0.000000317. Can? Okay, I shall not insult your intelligence by asking you to do try 11. Because I'm sure everybody can do it. Okay? Now let us move on to the computation. How do we work with standard form? With our calculators. All of you have experience using our calculators for at least 2 years already. You should have tried inputting numbers such as 6 to the power of 8, for example. Everybody knows how to do that, right? Everybody knows how to do maybe 3 to the power of 5, yes? Do you all know how to input 3 to the power of negative 4? Same way, right? So if you look at your button on your calculator, if you are using this Casio, you'll notice that there is a button that has an X with a square as the power. Or you can use that to input 10 to the power of something. For example, if I say enter in your calculator 10 to the power of 3, you can just press 10 and then you press the X with the square and you press 3. So you get 10 to the power of 3. You press equal, you get 1000. So that is 10 to the power of 3. There is a shorter method. If you can find it on your calculator, above the log, right? You see in yellow color, 10 and then a square, right? And they have that button there for your convenience. Because standard form is a standard way of writing things. And many people use it. So for your convenience, you can just press Shift Log. Then you have 10 to the power of. And then you can just key in 3. You get the same value, 1000. Okay, you can try it out yourself. This also works for negative powers. Okay, whatever your preference is, if you prefer to write 10, if you prefer to key in 10 power something, if you prefer to use Shift Log, it is fine. Okay, let's go into try it 12. Okay, looking at the example in try it 12, I want you to use your calculator and write down the value. Not a difficult task. All you need to do is just to be careful and be familiar with your keying in. Okay, so what did you get as your answer? Anybody got the answer already? At least you should know, you should have a value in your calculator. And does it look like this? With the correct number of zeros? Do you have that? Okay, then, is this my final answer? No, not so simple. I need you to do something very simple. Convert it to standard form. Can you do that? Okay, next one. Please try it. What do you all get as the answer? Can? You all get this? You did? Put a little green tick on your work. 7.649 times 10 to the power of negative 13. Is anybody facing any issues so far? And when we ask this kind of questions, we really need your feedback. Because if you are stuck somewhere and you don't tell anybody, then we move on, you'll be at a disadvantage. So does anybody need me to explain anything over here? Okay, which part? Do you manage to get A? You didn't get it for B. Can I see what you keyed in your calculator? Okay, so during your exams, we are probably not going to give you such easy questions. What you probably would see will be in, for example, try it 14 part A. Try it 14 part A. So let us try that question. If you need to use brackets, please go ahead. If you are using fractions in your calculator, make sure you know what you're doing. Check that the presentation in your calculator is correct. Because sometimes where you key the brackets, where you place the numbers, it will make a difference. So do it carefully, everybody should get the same answer. Okay? Yes, leave the answer in 360. Okay, basics, trees, difficult figures. Okay, now, as I was walking around, I noticed something. Some of you did it this way, huh? Okay, some of you did your work this way. Do you think you'll like it? Can you even see what I'm writing? Very difficult, right? Hey, when you're doing maths, it's not really the time to save paper. My recommendation, my advice to you is use 2 lines if needed. 2.37 times 10 to the power negative 6 over 4.18 times 10 to the power 5, blah, blah, blah. Okay? Don't go and squeeze all your working together. If it is very difficult for me to read, I'm sure it will be difficult for yourself to read and for yourself to check subsequently. Okay? So that's all I have for standard form. And let me give you the homework questions. Quite a simple topic, right? But I need you to keep practicing. So question 1, 2, 3, 5, 9, 8, 9, and 10. It may look like a lot, but if you look at question 1, 2, 3, they won't take you very long. It's just getting used to the standard form only. Okay? And these questions don't even need working. Practice, check your work, mark it. This is due on Wednesday. Okay? Any questions before I move on to the next topic? The boys over there, any questions? No? Okay, now, remember last week I also talked to you about interest, right? And how many types of interest have you encountered? The bank interest, right? Probably so. Have you heard of this term called simple interest? Simple interest, you all should have learned that already. Do you remember what is the formula for simple interest? If you don't remember, it is found on page 30 of your textbook. It says the interest I is equal to P times R% times N. This is found in your textbook, page 30. Recap. Do you know what P is? Principal. That means the amount of money you put into the bank or the amount of money you loan. What is this R%? That's the interest rate. Okay? Interest rate. What about this one? N is the number of years. Okay, so simple stuff. For example, let's look at example 20. On your textbook, page 28. Part A. A sum of 6,700 invested at interest rate of 8% per annum. So we write P dot A dot as an abbreviation for per annum, that is per year, for 5 years. Calculate the total interest if it is calculated as simple interest. So with all this information, can we substitute it into our formula? The formula over here. So what is the value of P? Okay, 6,700 times 8. Should I write 8 or 8%? What do you think? Should I write 8 or 8%? Or should I write something else? 8%. Yeah, let's follow the formula, 8%. Times 5. Okay. So this is actually 6,700. By the way, 8%, how much is that? In a decimal. How much is 8%? Okay, in a decimal it is 0.08, or we can call it 8 over 100. Okay, or the same as 6700 times 0.08 times 5. These are acceptable. What is not acceptable is somebody writes the interest is equal to 6700 times 8 times 5. This is not acceptable. Because the value over here will be different. Can? I need you to be very clear about your percentages. So over here, we will be able to calculate the simple interest to be 2680. Yes? Enough? Up some more. This one is in your textbook, page 30. Anyway, you can also go and watch the video, right? That's why we are recording all these things. Okay? So this is what is known as the simple interest. Yes. Okay. So this is simple interest. And do you think our bank works this way? Do you think our bank works this way? If you notice and you leave the money in the bank long enough without touching it, today I put in $1,000. 1 year later, by the way, do you know what's the bank interest rate? Every bank is different, but you know if you put in your savings account, right, how much is the savings? The interest? Probably 0.01%, right? We're talking about percent, So let's just take a look. If interest equals to 0.01%, this is actually equals to 0.01 over 100, which is actually 0.0001. Okay, these are all the same numbers. If this is the interest rate, and today I put in $1,000 in 2018, principal equals to $1,000. How much do I get as interest after 1 year? Equals to 1,000 times 0.0001 times 1 year, isn't it? After 1 year. How much is this? How much is this? How much? Quick. $0.1. That means 10 cents. After 1 year, the bank gives you a grand total of 10 cents. Okay? Now, if I don't touch the money, I leave it in the bank. Okay? Thank you. If I leave it in the bank, what do you think happens after 2 years? Is it going to be, so at the end of 1 year, your account balance is $1,000.10, right? This is after 1 year. If I don't do anything to it, after 2 years, do you think you will see it interest equals to 1,000 times 0.0001 times 2, which is actually 20 cents? Do you think this is the amount you will see in your bank? Do you think this is the amount you will see? Actually not. This over here is interest based on simple interest. Okay? That means the bank only looks at your original amount you put in. Okay? If we are calculating based on simple interest, the bank only looks at the original amount you put in. Then every year, give you 10 cents only. Well, you have to wait for very long before your money really grows, isn't it? Every year they give you 10 cents. But that's not how banks work. In fact, they work on something called compound interest. So let me illustrate with an Excel sheet. What actually is happening. Okay? Okay, over here I have a table. This is with reference to example 19 in your textbook. Compound interest. So this is different from simple interest, okay? Our banks, they work by compound interest. Let's say your original principal is $2,000, okay? With an interest of 5% per annum, how much do you think the interest is after 1 year? Watch what I'm doing. So the interest, this is going to be equals to, how much is it going to be equals to? The principal, which is 2,000, multiplied by 5%. Yes? You understand what I'm keying in? The D5 over here, I'm using a spreadsheet because it makes things easier for me later on. The D5 over here refers to the 2000 over here. See? D5. Okay? D5 times 5%. Okay. How much is the interest? $100. Did you get the same value when you calculated? So this is the power of Microsoft Excel. It helps you do calculations. Okay, now that I have the interest, what is the total I get after 1 year? Okay, you calculated it yourself, right? But I like to use the computer to help me. This is equals to 2000 plus 100. Makes sense, right? 2100 after 1 year. Sounds like it's better than putting it in a bank, right? Because just like we said, $1,000 you only get 10 cents. Whereas this one you put $2,000, you get $100 extra. Okay, this is after 1 year. Now, at the start of the second year, do you think the principal will still be 2,000? You imagine, you put money, banks want you to put money with them. Because once you put money in the bank can use your money to go and invest, they earn more money, and then they give you a little bit of interest. Okay? So banks love it when you put money with them. Now, in my first year, I put in $2,000. So the bank had $2,000 to play with. They gave me an interest of $100 after the first year. So now, at the beginning of the second year, how much money does the bank have to play with? The bank now has $2,100 to play with, right? I leave the money in the bank, $2,100, I'm not taking it out. Should I expect more interest this time? Should I expect interest that is greater than 100 this time? I should. Because originally I put in a small amount of $2,000, they gave me interest of $100. Now I put more. I have, this value is equals to $2,100. Now with $2,100, I expect more interest. And how do I calculate the interest this time? Okay, so now look at the calculation. The interest is still going to be equals to principal, but now my principal changed. Okay, times how much? 5% again. How much is my interest now? 105. Isn't that better? In the second year, my interest has increased from 100 to 105, right? Anybody doesn't know how I got 105? Who don't know? Raise your hand. Okay, then the last column, very easy, right? How much is the total? I add this column, this cell plus this cell. 2205. Yes? Okay? Can I continue? I can. In year number 3, this value is going to be equal to 2205. Okay? Now with this as my principal, I can again calculate my interest, right? How much is my interest this time? Now you all don't really want to say already because it's getting difficult to calculate. But never mind, I have my Microsoft Excel. This one times 5%. Oh, now I get interest of 110.25. And my total is now 2205 plus 110.25. Okay, you see my money growing? You see the money growing? Faster and faster, isn't it? Okay, so hey, what's the point of doing all this? Still quite troublesome. So this is what I'll do. Okay, all this, let's drag it down. Okay, now all these are zeros because I haven't filled in the rest of the cells yet. Okay, so this value 2315.25 was from here, and then all these, see, D6 times 5%, D7, lag. Okay, D7 times 5%. Copy down the formula. Copy it down. And finally, over here, it is just an addition of the 2 cells before it. Let's put it down. Let's see what we get. Okay. So what do you think? I saved a lot of time in calculating, right? Okay, so what can we tell from here? If the interest is 5% per annum, and every year I get an amount of interest, I add the interest to the principal, I get a total. Then the total becomes my new principal. Then I times another 5% to get the interest, I add it up, then I get a new total, and I keep doing it on and on forever and ever. Okay? So, before I go into the calculations, what are some things that you realize from this table? How long does it take to double your money? we start out with $2,000, right? Without doing anything. $2,000, I leave it in a bank that gives me 5% per annum without doing anything. When do I double my money? Around the 15th year, right? At the end of at 15 years, I get about $4,000 already. 3,959. Good deal or not? Is it a good deal? Without doing anything, you double your money after 15 years. Okay? So, can we find such a bank in Singapore? Yeah, you go and find out more. Where can we get such good interest rates? Okay? Because everybody wants to make more money without doing any work, isn't it? So you go and find out more. Hey, then what about loan? Taking a loan. What if we take a loan for, let's say, a credit card? Credit card, if you don't pay your credit card bills, they're going to charge you interest, isn't it? And they're going to charge you a lot of interest. And it is compounded interest. So at the end of this month, you don't pay the money, this is the interest. And it's going to be added on to your principal. The next month, we're going to calculate the interest based on your original principal plus whatever you owe. So your debt will keep growing bigger and bigger. Okay? So whether it is, these are the differences between the compound interest and simple interest. In simple interest, the value over here, it does not change. Whereas in your compound interest, the value of the interest will keep changing. Okay? Mr. Wong, during the exams, I don't have a laptop to do all these calculations and everything. How? Is there an easier way for me to find out the total value? Instead of having to multiply by 5%, add to this, find the new principal, year 2 times 5%, add the new principal, so troublesome. There is an easier way. The formula is found on page 28. Okay, if you turn with me to your textbook, page 28. On page 28, we have the compound interest formula. Okay, what does it say? AN equals to P1 plus R over 100 to the power of N. Let us compare this with our simple interest formula. We had earlier on I equals to how much? P times R percent times N, right? In our simple interest, this one is compound interest. This one was our principal. This over here is also our principal. Same P. Then I had over here interest rate. Okay, but notice that in the page 30 of your textbook, they left it as R percent, right? And over here, we also see an R over here, right? This one. Interest rate per period. This one we call it per annum. Okay, notice the subtle differences. In your simple interest, it is interest rate per annum. Over here, we have interest rate per period. I will elaborate a little bit more. What is the difference between a period and an annum? Okay, by the way, R percent is actually the same as R over 100. So mathematically, they look like they are the same thing, R over 100. And finally, over here, this N is the number of years. In this case, we have number of periods. Compare that to per annum and years. Okay, later on in the examples, we'll see how these terms are very important to answering the question correctly. Okay, now, in our simple interest, what we always know, the simpler one, after I do this calculation, I get an interest, right? But in my compound interest formula, this AN is not the compound interest. This is the total amount. Okay? This is the total amount, AN. What is total amount? Do you remember our Excel sheet? That total amount over here. You take your principal plus the interest, you get a total. So this is the total amount AN. Then what happens if you want to find the interest? Let's say we apply this formula and I find out that the total amount is 1,100. Suppose principal is equals to $1,000 and the total amount is equals to $1,100. How much is the interest? Yep, it will simply be the total minus the principal, which is just $100, okay? Any questions for this so far? I want you to know the differences between your compound interest and your simple interest. Okay, simple interest formula just gives you the interest. Compound interest formula gives you the total amount. So if you need to calculate the interest, you need to subtract the principal. Okay? Okay. Now let's go into an example to see how we can use this. We go back to example 20, part B now. We've done part A already. Example 20, part B. Okay, same thing. Principal equals to 6,700. Okay, with all this information, can you find out what is the answer for part B? Compound interest that is compounded yearly. In this case, we need to use our formula already. AN P 1 plus R over 100 to the power of N. Okay, substitute it, all the values in. N is equals to 5. Okay, N is equals to 5. So at the end of 5 years, this is what I will have as the total amount. 6,700, that's my principal. 1 plus R, the value is 8 over 100 to the power of 5. Calculate this, tell me what you get. Okay, it will be something, then you round it off. 9844.50. 2 dp. Hey, why? Oh, okay. We are now on question example 20b. Okay. We've done 20a. That dealt with simple interest only. In 20b, the question asked us to find the compound interest with all the same principal, same interest rate, same duration. But the difference is the way it is calculated. It is compound interest this time. So as with all compound interest questions, you need to apply the formula. Okay? Formula is found on page 28. I'm going to highlight the formula. This is the formula. With the formula, we can simply substitute in values that are known, that we know of. For example, the value of n is equals to 5. So I replace all the n with 5. We also know that R is equals to 8. So over here I have an R, replace it with 8. Then I have my principal, which is 6,700. Replace this with 6,700. Okay, just by substitution, I will be able to get this line. Okay so far? Then just simply calculate, you get 9,844.50. My question was, why is it in 2 dp? Oh, you all learned it before. Okay, so when we are dealing with money, we leave it in 2 dp. Okay? If you are not dealing with money, then you leave it in 3SF. If it is in degrees, you leave it to 1 dp. Okay? So, hey, what does this value represent? What exactly is this representing? Is that my interest? Is this my interest? No, it is not my interest. It is the total amount. Right? In the formula, this over here gives me the total amount. Okay? Now, if I want to find just purely the interest, I need one more step. It's equals to 9844.50 minus my principal of 6,700. And I'll get 3144.50. That's my interest. Can? Okay. Now part C has the question worded a bit differently. Look carefully at part B and part C. What's the difference in the question? In part B, the amount was compounded yearly. Okay? In part C, the amount was compounded monthly. What does that mean? Remember our table? Over here, I calculated this compounded yearly. That means after 1 year, I calculate the interest, I add it to the total. Then I have my new principal. After 1 year, I calculate the interest again. Then I have my new total. Keep going on and on. That is compounded yearly. What do you think happens when I say it is compounded monthly? If your money is compounded monthly, that means at the end of every month, your bank will calculate your interest one time. So if this year, January, I put my money inside the bank, and if it is compounded monthly, at the end of January, they will calculate my interest, then they will add it to my principal. Then in February, they will calculate my interest again, add it to my new principal. Keep going on and on and on. So if it is compounded monthly, how many times do you think they will compound in a year? If it is compounded monthly, how many times do you think they will compound in a year? 12 times. Easy, huh? Let's change the question a bit. If it is, if the compound interest is, if it is compounded every 6 months, so how many times do they compound in a year? 2 times, one time in June, one time in December. What if it is compounded every 3 months? You know, every 3 months is called a quarter. Okay, so you have the answer. It is compounded 4 times. If it is compounded every 3 months. Okay? So if you notice in my definition of compound interest, in my definition of compound interest, we talked about this one, per period. So do you see why I highlighted this per period? In the past, when we talk about simple interest, we always talk about per year, right? Every year something happens, blah blah blah. But now in compound interest, something different can happen. I can either compound your interest every year, or I can choose to do so every month. If I choose to do so every month, then how long is one period? One period is 1 month. I compound it every month, so one period is 1 month. So in a year, how many periods will that be? Well, if I choose to compound your money every 6 months, how long is one period then? 6 months off? One period is 6 months. But how many periods will that be in a year? There will be 2. Okay, so you need to know how to calculate the number of periods before we can effectively apply the formula over here. Okay, so that is the end of my lesson for today. I will continue with this in your next lesson.